Hello YouTube, hope you're doing well. This time in the new programming language, I think that we made it to here, reserved words and identifiers. Let me verify we have this peek next function. It seems we do. So, we're almost done apparently. The only remaining pieces of the lexical grammar to implement are identifiers and the close cousins reserved words. You might think we could match keywords like or in the same way that we handle multiply. But consider what would happen if we use and name the variable orchid. Then the scanner would see the first two letters or. Okay, maximal munch. Anyway. Okay, so maximal munch means that we can't easily detect a reserved word until we reach the end of what might instead be an identifier. After all, a reserved word is an identifier. It's just one that's been claimed by the language for its own use. That's where the term reserved word comes from. Okay, but to begin with, we add this, and then we call an identifier. And now the isAlpha function we need to implement. It is most likely going to be something like this. Actually, let's do this, and we don't have to write that all the time. And, or rather, it should be this, or it's a capital letter. C as U8 and as U8 here. Okay, I think that should do it. Yeah, interesting. So we also need this underscore character. I did not like that because it's called CH, and we forgot as U8, and we don't have the identifier thing yet, but otherwise it's correct. So how do we implement the identifier? And we always need a mutable self. I recently learned that you can write this, at least I think you should be able to write this instead of this. It's completely equivalent. And let's say I think we forgot to handle this error. Should probably do the same here. It's kind of interesting that it doesn't say anything about that. Is it really okay? Okay, now it's just the warnings. Maybe it's because it's buried in all these warnings. So let's search for unhandled. No. Number. Yeah, okay. Does say unused result. So let's do that. And now let's see how we implement this identifier function. So while is alpha, okay, we also need an alphanumeric function now. While is alphanumeric the next character, we advance, and once we have done that, we add a token. It's very interesting. Which we call an identifier. And then we do an OK. So, how can it fail? I guess it cannot fail, actually. So let's not return anything. Okay. And we don't have alphanumeric, so is alphanumeric. And it should be just either it's alpha or it's digit. And now we have the warnings. Okay, so that should work for identifiers. So let's just make a test. Get identifier. And the source should be something like this is a variable and equals to 212, sorry. Let's try that. Scan the tokens. We say it must work. And then it should have found 4 tokens, 1 identifier, 1 equal sign, 1 number, and end of file. I think it's 4. I can't remember if we have a token for the semicolon, or if we're even supposed to have semicolons in this language. Let's just try to run it now. And I really should get rid of all those warnings. So get identifier failed because it found 5 tokens. And how do we normally print tokens? Anyway, let's get a bunch of these guys. And actually I want them here. Okay, fine, there's 5. So semicolon is a token. That's great. Like this. And we want the first one to be an identifier. The second one to be an equal. Then a number. Then a semicolon. And then a end of file. And did not like that because there's no I variable, which makes a lot of sense. Okay, so that seems to work. But now that gets identifiers working to handle keywords. We'll see if the identifier select theme is one of the reserved words. If so, we use a token type specific to that keyword. We define the set of reserved words in our map. Okay, so some kind of static map, and I just looked it up. I think we can define it like this. So let's say keywords or whatever. It should be a hash map from and then all of this. Let's just do a quick check and see if it works. Great. We don't have the hash map, so we need to say use std collections hash map. Okay, didn't like that. So sure, it should be a hash map from string to token type. And cannot call non-const function from. I wonder if there's a way to get a static one. Does not look like it. Can we just do this? Yeah, no. Okay, so it's the time-honored technique of Stack Overflow. Let's see if this works. Still, it doesn't like this. But apparently you can do this thing. Let me try that. And I mean, we could just, can we do this? And then do hash map from no, that still doesn't work. Doesn't like to collect. How does this guy do it? He also has the clone. I don't see how that would change anything. And this, now it complains about it, but it doesn't complain now. Is it because token type cannot be cloned? Token type. Now it has a clone. Okay. Okay, I don't really see a way, unless we use some other package, and I don't really want to do that. Does this work? No. So how should we do this? I'm going to put it on the scanner then. So let's say keywords is this hash map. and when we make the scanner, we just call get hash map, and that will be this function. Get hash map. Why not get the keywords hash map? Hash map, nothing, but it returns this thing. Okay, let's format it. And now we can go on and copy all this. All right, here we go. So still seems to work. I had to add static lifetime just to tell it that these strings are supposed to live the whole lifetime of the program. Now we have the keywords. So then after we scan and identify, we can check to see if it matches anything. So here we have an apparently it's in here. So let's see. Again, we need a reference to scanned lexeme, and okay, do we have like a get function or something in here? Oh, here they are. So look up or something like that. Get joins a reference, and it's an option. Great. So let the let token type equal okay, let's do like this. If let some token type equals self dot keywords get substring, then we add a token of that type. Otherwise, we add an identifier. Let's run that. Okay, didn't like that. Expected. Weird. Can we do this? No. Okay. It's the same. It's kind of funny that it gives a it gives like a reference to it, but we want to copy it, I guess. So again, it's just like a really basic enum, so it should be no problem in copying it. Let's see if that now works. It gives warnings, it runs the test, and the tests pass. If so, we use that keyword's token type. Otherwise, it's a regular use definer. And with that, we now have a complete scanner. Nice. Type up some valid and invalid code to produce the tokens you expect. Try to come up with some interesting edge cases. All right. That means for us, we will now write a last simple test, and we will see if it works. So we have that. Let's add another line where we have something like for I in something like this. No, that will not work. So we can say while true something print 3. Okay. And with that, unwrap, so run it, just to, oops, check that it runs. let me just check this one thing. It says unused map here. Does that mean I can do this? And now it will complain. Cannot be applied to that. What am I supposed to use this map for? Don't understand. Okay, but at least I don't think that, I think that warning is gone now. So we scan the tokens and we do this usual thing. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 tokens, and the first one should be var, then identifier, semicolon, then while, true, brace, print, number, brace, semicolon, end of file. Okay. So while, true, left brace, print, number, right brace, what did I do wrong? Forgot the semicolon. Okay, so 5, 6, 7, come on, 8, 7, 8, 9, 10, 11, 12. Run it, check it, and that was okay. So seems like we've implemented a scanner, and let's see what the next thing is. There's a lot of challenges. I think we will just skip that, but I guess it's in lexical grammars of Python and Haskell, not regular. What does that mean? Why aren't they? That's interesting. Good look at that. To dwellers in a wood, almost every piece of tree has its voice as well as its feature. So, representing code, context-free grammars, syntax trees, working with trees. Interesting. So now we'll actually start to parse code and put it into a structure that can be executed. Okay, see you next time.